Good evening. Today we are going to see the clauses related with loads which we require in roof trusses. Now in roof trusses we are going to consider three loads. One that we have dead load, then second we have live load or imposed load, and third we have wind load. So these three loads we have to consider in roof trusses, and we are going to see the clauses related with these loads. So dead load we have IS 875 part 1. Then imposed load we have IS 875 part 2. Wind load we have IS 875 part 3. So we have to go for these three codes for different loads, and we will see one by one. In detail, we will see when we will go for the practicals, but now we will see overall clauses which are for these loads which we require to design the trusses. So now we have first, that is dead load. Already we have seen part 1, 1987 was the year of publish. Then this table that is given on page number 5 of IS 800, and we require, because now in roof trusses we have sheets, and two types of sheets we are going to consider over there, that is roofing sheets or roofing material we can see, and we have two types. One is AC asbestos cement sheet, and second we have GI galvanized iron sheets. And that weight of these are given in this table. So you can see this. Here this is given depending upon your nominal size of thickness. We have this value 0.118 to 0.130, and the unit is kilonewton, and this is per meter square. So we have all these values per meter square. So we can say this value ranges between 90 to 130. But nowadays, if you will see, then we have number of manufacturing companies are there which are manufacturing these sheets, and according to their materials, these values are a range maybe 150, 170, and that depends upon your thickness and quality of the sheets. Then we have in the same table, that is table number 1 and page number 10, we have atom number 39, in which we have given self weight of GI sheets, galvanized sheet. And here you can see class 1, class 2, class 3. Likewise, nominal size of thickness in mm is given, and you can see this value again ranges between 52 Newton per meter square, so 131 Newton per meter square. So we have these values which ranges between these, and again nowadays depending upon your manufacturing uh, companies, these values may range, may go 140, 150 we have likewise. So these are the dead loads which we have to consider from IS 875 part 1. Along with this dead load, sheet rest on purlins. So we have to consider self weight of purlin, which generally taken as 100 Newton per meter. And then we have self weight of truss, which will be taken as span by 3 plus 5 into 10. That we will see when we will go for actually problems of these trusses. So here we are interested what clauses we have to refer to different IS 875. So for dead load, we have this IS 875 part 1. Now we have IS 875 part 2, and we have to use this for live load, or you can say this also as imposed load. And if you will see this table, which is on page number 18, is used for trusses. Now you can see over here for sloping or curved roof with slopes up to and included 10 degrees. So up to 10 degrees, access provided, we have value 1.5 kilonewton per meter square. Now, whatever dead load of sheet we have, that is on inclined area, because sheet are on inclined portion. And this, if you will see imposed load, we have this on plan area. So if you will see like this, then we have this as plan area and we have this as inclined area. So this is inclined area, this is plan area. We have to multiply it by distance. So now access provided, if access is provided on the roof, then we have to take that value as 1.5 kilonewton per meter square. And minimum we have to consider, that is given 3.75 kilonewton uniformly likewise. So now access not provided except for maintenance. So if you will see, then most of the times we will come across these trusses in industries. And then in that case, your value is 0.75 kilonewton per meter square. And then again, that is written 1.98 kilonewton, which will be minimum values. Now, sloping roof with slope greater than 10 degrees. So up to 10, we have this. And above 10, we have these values. Now you can see in this case, we have for roof membrane sheet or for purlins, 0.75 kilonewton per meter square less 0.02 kilonewton per meter for every degree increase in slope over 10. What does it mean? 0.75 minus 0.02 in bracket theta minus 10. So we have, this is the formula to calculate live load or imposed load when my value of theta is greater than 10 degrees. What is minimum value? That is given as zero point 0.4 kilonewton per meter square. This value is kilonewton per meter square. Now curved roof with slope of line, so we are not going for this because we are not dealt, or our syllabus is not dealt with this one. Here they have given gamma, and gamma we have, that is h by l. So we are not going to be with this. So we are with this because our slope theta, that is greater than 10 degrees, and then we will use formula of live load 0.75 minus 0.02 theta minus 10 kilonewton per meter square. So we have this clause. Then we will switch over to the wind load, and I already mentioned this is IS 875 part 3. And then we have on page number 5 this formula, which is Vz equal to, so this I will directly, because I will not read this, the basic wind speed, that is as figure 1, that we will see in next slide, and shall be modified to include the following effects. Which effects we have to include? Risk level, terrain roughness and height of structure. And for this one, these different coefficients are included in this. So we have K1, this is probability factor, that is risk coefficient. Then terrain roughness and height factor, we have K2. Local topography, you can see we have K3. And for importance factor for the cyclonic region, we have K4. So to include these factors, we are going to include these four coefficients K1, K2, K3, K4. VB, we have design wind speed at height Z in meter per second, which is Vz, and VB actually we have basic wind speed. You can see over here. And we have, or our India, that is divided into 6 parts. And for that 6 parts, we have these different values starting from 33, which is minimum value meter per second, to 55 meter per second. So we can have this, so you can see this. So we have these different areas. So if we will go, we have this as 33, then we have this value 39, then we have 44, then we have 47, then we have 50, and then we have this 55. So likewise, we have these zones, or India is divided into these 6 zones, and we have this value of basic wind speed in this way. That value we have to consider from this map. We have given region, and according to that region, we have to see from this what is my basic wind speed. Then we have seen these four coefficients. So K1, K2, K3, K4, and these are given. That is table 1 we have on page number 7, IS 875 part 3, that is risk coefficients given. Then all general buildings and structures, we have mean probable design life of structure in years 50 we are going to consider, and K wind factor for basic wind speed. So we have that region, and for that one these values are given. Then temporary shades, building and structures presenting a low degree of hazards. So we have this K1. Now we will go to K2. So now we have K2, that is on page number 8, and that depends upon your terrain categories. Terrain category 1, 2, 3, 4, and we have given category 1 exposed open terrain with a few or no obstructions, and that is structure less than 1.5 meters. So this is difficult one. So terrain category 1, so very rare you will come across shades like this. Then 1.5 and 10, between these we have given, and open terrain, well scattered obstructions having height generally between 1.5 and 10 meter, we may have like this. Then we have like category 3 also, that is terrain with numerous closely spaced obstructions having the size of building structure up to 10 meter in height or without a few isolated tall structures. So in industrial area we can have this category 3, and then we have category 4, in which we have terrain with numerous high closely spaced obstructions. So these also we can have when we will say in large cities. So likewise we have to consider value of K2 from this table. And then we have next, that is K3. That K3 actually we have given, that is in Annex C, and in Annex C they have given two diagrams. From that one formula is given, and from this we have to calculate actually K3 value. So we are not going to be with this, we are going to consider value of K3 as 1 only. Then we will switch over to K4. So now K4, that is given for industrial structures 1.15 and all other structures 1. So we are going to be with industrial structures. So we are going to consider K4 as 1.1. Now, once I know this value, so we are going to calculate this value, that is Vz, and that Vz we have K1, K2, K3, K4 into Vb. And once I know Vz, I can find Pz by using this formula, that is clause number 7.2, which is on page number 9. So Pz equal to 0.6 Vz square, and Pz is wind pressure at height, Z in Newton per meter square. Once I know value of Pz, I can find Pd, which is designed wind pressure. Now we have to go for Kd, Ka, Kc. Kd, wind directionality factor, area averaging factor, and combination factor. But we should be Ka, Kd, and Kc. This value should not be less than zero point 0.7, not less than 0.7. So we have to assume this value 0.7 or greater than that one. So now we have wind directionality factor. So for triangular, then square and rectangular, we have that factor as 0.9. So we are going to consider this factor 0.9 kg. This clause is given on page 9 and 10. So now this 7.2.2, which is given again page 10 for value of Ka. And for that when we require tributary area, and this tributary area they are going to say this is distance between frames. So we are going to consider these frames, that means trusses, distance between the trusses, and then second in other direction together with the individual panel dimension in other direction, and we are going to consider center to center distance between purlins. And accordingly we have to consider this value of area, and for that we have less than or equal to 10 meters square 1, then 0.9, and then 0.8. So our value generally ranges up to 10, and then we can have this value as 1. Then Kc, so they have given this value, that is reduction factor, as 0.9, and so knowing Ka, Kd, Kc, we can find value of PD. Now, once I know value of PD, then from page number 10, clause number 7.3.1, I can find this wind load F, which is CPE minus CPI into A into PD. Now, A, we have surface area of structural element or cladding unit. Then PD, we have design wind pressure, which we have calculated from last slide. So now we have to see CPE and CPI. CPE external pressure coefficient and CPI internal pressure coefficient. So first we will go CPE. This is given page number 6. Table number 6, page number 14 from IS 875 part 3. And here we have theta equal to 0. Now you can see when I have theta equal to 0, it is perpendicular to this truss, that is normal to the truss, and when theta 90, it is along, means parallel to this truss, and that values are given here. This value alpha, that is our angle of inclination of the truss, and then wind angle theta, EF, GH. EF means we have windward side, and GH, so this is leeward side and this is windward side, and accordingly we have to consider these values and we have to go for all these combinations. Now here H by W, H we have height up to the bottom of the truss, and W we have span of the truss, and calculating H by W, we have to decide which part of the table we have to use to determine value of CPE. Once I know CPE, then I have to go for CPI. For CPI, we have three actually categories. First category we have when opening is less than 5%, we have to consider value plus minus 0.2 openings, that is of wall. So here you can see the cladding permit the flow of air, or here you can see depending upon the degree of permeability of cladding to the flow of area. And here we have this value for opening about 5% of the wall area, and then in that case we will go plus minus 0.2%. Now we have on the page 11 same clause 7.3.2.2. So if my openings is between 5 to 20%, then I have to consider this as plus minus 0.5, and when my opening, the area that is greater than 20%, then in that case I have to consider this value as plus minus 0.7. So we have to consider this value as CPI. We have seen CPE, and then once I know these values, then we are in position to determine the trusses, and determine the loads, and once I know the loads, then we are in position to design the trusses. So remaining part we will see in the next lecture. So thank you.